Today we're going to talk about rotations, and our goal is to be able to graph and identify rotational symmetry. So we're going to graph it, and then we're going to identify shapes that have rotational symmetry. And we'll talk about what rotational symmetry is on the next slide. But before I begin, let's review the type of angles that we have. So we want to classify each angle as either acute, right, obtuse, or straight. Now, if you remember your angles from elementary school, you learned the 4 different types of angles. And if you remember, you drew a straight line, probably drew a straight line. And that straight line we called a straight angle. And that was 180 degrees. And if I drew a line in the middle of that and I formed the perfect corner, if you remember that, we said that was 90 degrees. And we called those right angles. And 180 was straight because it made a straight line. And the 90 degree angle made a right angle. It made like a corner. And in between those two angles, you had everything less than 90 degrees. And we called those acute. And we had everything greater than 90 degrees but less than 180. And we called those obtuse. So anything that was bigger. So knowing that, we can identify these. So 180 degrees, what type of angle would that be? That would be a straight angle. And my pen doesn't want to work today. Or any day, apparently. And 150 degrees, again, that's between 90 and 180. So that, again, is going to be a straight angle. And 95 degrees, that's still bigger than 90 degrees. So that's still going to be yet another straight angle. And 20 degrees is going to be somewhere in here, like maybe that big. So that's going to be an acute angle, and we talked about that. It's a cute little angle. And then 90 degrees is a perfect corner, so we call that a right angle. All right, let's look at some vocabulary words for this section. The first vocabulary word that we want to look at is rotation. Now, just like we've done all kinds of transformations in the past, a rotation changes the figure in a certain way. A translation slid the figure. A reflection gave you a mirrored image, and a rotation turns the figure about a fixed point. So the transformation turns the figure about a fixed point, or around a fixed point. Now, speaking of that fixed point, that is also called our center of rotation. So when I'm talking about the center of rotation, I'm actually talking about that fixed point that I'm rotating it around. The other vocabulary word that we want to discuss is the angle of rotation. And the angle of rotation is the number of degrees that it rotates. Now, we measure how far it rotates by degrees, not inches or feet. It's by degrees. And if you've heard of degrees before, you can think of like a degree of an angle. So we're looking at how many degrees of that angle it rotates. I'll give you a minute to copy that down. And the next one we want to talk about is rotational symmetry. Now, the rotational symmetry means that if I can take a shape and I can rotate it 180 degrees or less. So if you think of 180 degrees, you're thinking of a straight line or less than that. And after I rotate it, it exactly matches the original figure. So you can't tell if I rotated it or if I just copied it down. So rotational symmetry is just that. The shape can be rotated 180 degrees or less, and it exactly matches the original figure. Now, talking about angles, I wanted to show you, this is what we call polar graph paper. And it's a graph paper, and people do use it to graph, but it's used to graph degrees. So when we start, we always start at 0. So if you look over here, you see 0 over here. That's your starting point anytime you graph. So if you are going to graph an angle, and say you want to graph a 50-degree angle, I would start here, and I would start graphing up until I hit 50 degrees, which would be right about here, because these are counting by 5, so that would be 50 right there. And that would be my 50-degree angle. So as you can see, if I take a point, say I take this point here, and I rotate it 75 degrees about the origin, this is your origin just like it is on an XY axis, you are going to rotate it 75 degrees. It's going to come up here, and that's going to be its new dot. If I take a dot and I want to rotate it 135 degrees, so it's here, it's this far away from the origin, so when I finish it should be that far away, so I'm just going to follow my line. 135 degrees would take it here. If I pick a point and I want to rotate it 225 degrees, that's okay too. I might pick it here, start right here, and I'm going to go 225 degrees. Let me change colors. So I'm going to follow, this is 90, this is 180, and 225 is going to be here. Notice I'm following my numbers out here. Now, what do you need to know? You need to know, before we begin, that this from here, from 0 degrees to here is 90. And you need to know from here to here is 180. And you need to know from here to here is 270. And from here to here, the whole way around the circle, is 360 degrees. So if you don't know that, I would write that in my notes. Maybe draw the axes, and notice that from 0 to the top is 90, from the top to the left side is 180, and from 180 to the bottom side is 270, and all the way around is 360. So if I tell you do a 180, when we say people do a 180, it means they flip to the other side. Notice that if you forget what these numbers are, this is 0 plus 90 gives you 90, plus 90 gives you 180, plus 90 gives you 270, plus 90 gives you 360. So if you forget what the numbers are, you can always add them. All right, now we want to take the point A, and we're going to rotate it 90 degrees, and we're going to rotate it counterclockwise. Now, what does that mean? Well, if you think of a clock and how a clock runs, it runs from 12 o'clock to the right. So clockwise goes to the right. So if this was 12, it would be 3 o'clock, 6 o'clock, 9 o'clock, 12 o'clock. Counterclockwise goes in the counter direction. It counteracts it. So that means we're going to be rotating it 90 degrees to the left. So keep that in mind, we're rotating to the left 90 degrees. So we need to pick our axes of symmetry, and our x-axis is normally where we would rotate, but this A is not on that. So we're going to draw a line from the origin to the point. So this is from the origin to the point. And that's going to be from where I'm going to draw my 90 degrees. Now if I rotate this 90 degrees, it's going to rotate all the way to there. And you can take your paper and you can write it. You can rotate your paper to see that. Now if you notice here, my point was at 5, 2. And what do you notice about the point of the image? What are the coordinates of that point? That's what I want you to look at now. So write that down and we'll talk about that then. Now for this next one, I want you to copy down the triangle ABC into your notes. So copy down each of those points, A, B, and C. Where are they? What are their coordinates? And then I want you to rotate it 90 degrees counterclockwise. So I want you to rotate this 90 degrees counterclockwise. And then I want you to tell me what the points, the new points will be. So you may stop the recording, and I want you to rotate this 90 degrees counterclockwise.